Good morning everyone and welcome to the NPTEL course Advanced Distribution System Analysis and Operation. We are continuing with our module 11, that is cyber physical layers in distribution systems. And in the last class we have seen what are the mediums we are using, why we are using, and how the communication process is carried out in the power communication system. Today we will see that obviously no communication system or no system in real life is ideal system, like what we are expecting that we will get. Obviously that will be contaminated by some impurities. So this non-ideal things or non-ideal scenarios what is present in the communication mediums and how we can model them in an analytical manner. So what makes a communication system non-ideal? First we have to see that. The first one, that is the erroneous data. That means when you are doing that digitization or you are doing the masking or even with the cyber attacks, your data has been tampered and you are sending that morphed data. If that is there, then it is called erroneous data transfer. Second, packet loss, that means data packets are lost in the transmission due to interference or congestion. That means you are sending something, but as it is a very highly congested medium, so at that time it has not even received at the receiving end. So we call that data is lost in the medium. Okay. Then additive noise, that is the electromagnetic or signal interference can corrupt the transmitted data. If you have another power line or another communication line in neighborhood, so you will get some interference from that line with the original data. So that will add some electromagnetic effect and that electromagnetic effect will be added as a noise with the actual communication or actual data transferred. So that is called as additive noise effect. Then obviously last is the delay, that is the time taken for a signal to travel from sender to the receiver can affect the real time control. There is a difference between this packet loss and this delay. Delayed communication means the data will reach, but reach in some after some time. But packet loss means the data will never reach, it is lost in the medium. So if it is infinitely delayed, then we call it packet loss, or if it is delayed in a finite interval, then we can call it a delayed medium. First we will see how we can model this erroneous data transfer. The error in data transfer may occur due to quantization, encoding or decoding process. When let us say this is an analog signal and we are quantizing it in a process and then making it as a digital signal. So, in that quantization process, if that levels are not justified properly, so at that time you can get the quantization error like this. So, you can see this error does not have a proper pattern. It may be a hybrid pattern or it may be a random thing. So, it is mostly it is add as a random events with your true data. So, whenever you will mathematically model that erroneous data transfer is expressed by adding a random data with the true data shared. Okay. Considering a non-occurrence probability, that means this error may or may not occur. It is not necessary that you will always do the like misinterpreting or you will do some mistake for the quantization time or digitization time. Sometime you can do, sometime it is possible that you are doing perfectly. So, if that is the case, so there is some occurrence probability of that quantization error or that error. So, depending upon that, the actual value of the shared one, you can see this is the true plus the error, where error is 0 if the non-occurrence probability, if your data probability occurrence is lesser than that actual your setted limit and it is some value, random value elsewhere. So, chi is the random error non-occurrence probability and u1 and u2 are the uniformly generated random variables between 0 to 1 and minus r to plus r. Okay. So, this u1 will give you a probability value like a random event. If it is a less than non-occurrence, that means it is a non-occurrence case. If it is a greater than non-occurrence, that means it is a occurrence case, it is a reverse one. So, if that is the case, at that time you will get a error, and that error range or that magnitude of that error will be again randomly defined by a minus r to plus r range, which where r is the highest possible level of the error. So, that means your error can be of negative side as well as the positive side. That means that will reduce the actual value or that can enhance the actual value. So, depending upon that, this error is modeled. Then packet loss, an event where one or more data packets are lost in the channel, that means sent from the transmitter but not received at the corresponding receiver. What I told, that infinitely delayed. How this has happened or why this happens? First, a faulty connection, that means your communication medium is faulty, it is broken. If that is the case, then obviously we will lose some data. You have very highly congested or very highly trafficked communication infrastructure. That means if you are sharing that with a, let's say, voice call, if you are using cellular network, so you are sharing the wireless cellular network for your power data sharing as well. Okay. So, if that is the case, then you will get highly traffic. So, that means your data will be lost or data will be delayed. Outdated service or software use, that means you are using some bad or very old software, so that cannot handle the new data. If that is the case, that it cannot receive also that new data. More data than the device capability, that means if it is able to design for the bandwidth, let us say 10 kbps, and you are sending data of 15 kb of per second, 15 kilobits per second. So, that extra 5 kilobit data it cannot handle. So, that will be lost. Then the distance, if your communication lines are, let us say, very long and you are not using amplifier, as we have mentioned in the optical fiber connection. So, that means your data will be lost after some time. If that is the case, then also you will experience packet loss, and if there is any denial of service attack. So, that means it is by the hacker or by the attacker, it is saying or it is creating an, you can say, a congestion, that is a mimicked congestion scenario, that will say that the data is not reaching. So, if packets are lost, the reduced amount of data will reach at the receiving end, and that will impact the performance of the network, that is obvious. So, you are sending some data, it is not receiver end, but it is dropped in between. So, how you can model that packet loss event? The packet loss is modeled as an independent random event which can happen anytime in the communication medium, because anytime the line can be congested. Okay? Anytime you can send more data than your actual rating, bandwidth rating. If that is the happen, like let us say suddenly a fault occurs. So, your PMU is now sensing more data and it is sending that data to your system. So, it can happen randomly. So, the model this random event, a packet drop probability is initialized. Okay. Therefore, a message is dropped if a uniformly generated random variable is lesser than p, same like your previous one. If the probability is lesser, then you can say, if it is lesser, your random event, that is lesser probability, if your defined limit, that means at that time you can say the packet loss is happened. Each local receiver handles missing message data by using the most recent data that it is received. So, at that case, what normally the system do? It takes the data or considers the data which is the last updated data it received. So, depending upon that, it takes the decision. Now, additive noise, which is the most happening or unwanted events the communication medium experiences. The noise refers to any unwanted electrical or electromagnetic energy that disrupts or interferes with the transmission of the intended signal. Okay? Noise can distort the signal, cause errors in data transmission, and degrade the overall performance of a communication system. That means, you want to send something, the noise is added in between and you are sending something else. You can see completely changed. So, you will misinterpret that data. So, you will take erroneous decision. So, noise present in the communication circuit is dependent upon the choice of the channel. So, you are choosing PLC or choosing optical fiber, depending upon that the noise type also keeps on varying. So, we will see first what are the noises present in the PLC, power line communication. These are the normally two channels widely used for WAN or the NAN connection. We will not focus on the HAN connection, we will just focus on the NAN and the WAN connection, where generally wired connection is used, and for that normally PLC or optical fibers are mainly preferred. So, in case of PLC, noise is one of the major challenges affecting the data reliability and transmission of the system. So, in that case the power lines are used for data transfer. So, the noise level is very high due to electromagnetic interference between the power signal and other electrical appliances. So, you are superimposing your communication signal with your power signal. So, there will be obviously there will be interference between these two signals. Again, if your electrical appliances are turned on, turned off multiple times, so that will also give an electromagnetic effect, because everything runs, your transformer, your motors, everything runs on the principle of electromagnetism. So, that electromagnetism may have also effect on your communication data. So, broadly the noise can be classified into two groups, that is the background noise and impulsive noise. So, if you see the background noise, this can be narrow band noise or colored noise, and if you see impulsive noise, this can be periodic synchronous noise, periodic asynchronous noise and a periodic noise. So, the total noise in the PLC medium is given by the summation of these two noises. So, what is this background noise in PLC? This is a low level continuous and frequency dependent noise. This type of noise is always present in the channel, that is always present, like background noise you cannot get rid out of it. Okay. This you can see a narrow band noise, it is always present there. So, it can originate from natural sources like thermal agitation or man made sources such as electrical devices. Okay. Like whenever you will send the data, your power line will be heated up. So, that heating effect also has some background noise. So, you have nothing to do with it, that is obviously happened, that is already always present in the PLC medium. So, depending upon that, there are different types of background noise. One is narrow band noise, which is continuous wave interference confined to a specific frequency range. Okay. Originates from nearby radio broadcast based on amplitude modulation. So, that is coming from nearby, let us say some radio station is there, that signal is also transmitted. So, that will have some interference with your actual power communication data. So, power spectral density is represented by summation of various signals which are represented by Gaussian function. So, this is the expression for the your narrowband frequency, narrowband noise frequency. So, n is the number of radio frequency disturbance sources, Bk is the bandwidth of the radio source, F0 is the central operating frequency of the radio source, and Ak is the strength of the radio signal. So, that is narrowband noise is mostly due to the radio frequency signal which is nearby the power lines. Then you have colored noise as well. This is called colored because depending upon that, the energy density or the power density, how it is confined to the different frequency spectrum. So, depending upon that, it is segregated into different coloring medium. If you have white noise, then equal energy across all frequencies. If you have pink noise, then more energy in the low frequencies. Brown noise, then even more in lower frequencies, very deep, that is compared to the pink noise. If it is a blue noise, then more energy in the higher frequencies. If it is a violet noise, then sharp higher frequencies, and gray noise, then balanced energy across frequencies to match the human perception. It is a black noise, then mostly silence or very low energy with occasional burst of sounds. So, different electrical appliances like nonlinear loads or transmission medium can filter and amplify certain frequencies, leading to noise with specific color characteristics. So, depending upon the power density at the frequency level, this noise characteristics is done, and that is why it is done in a very band, like making it as a color band kind of frequency level or the classification. It is not the actual colors, but due to this band it is named with some colors to identify them easily. So, that is why it is called color noise. So, generalized power spectral density expression for background noise is given by this expression, okay, where f is the frequency at which the power spectral density of the colored background noise is being evaluated. N0 is the constant component of the noise representing the baseline noise level, okay, and f1 is the reference frequency that control the rate of exponential decay. So, we model the background noise with the help of normal or Gaussian distribution with 0 mean and standard deviation of a certain value. So, as is an, you can say, this is a random one. So, any random event, it is very easy because it has a positive and a negative side both. Your noise can reduce the strength of the signal or enhance the strength of the signal. So, that is why it has a negative side and the positive side both. So, keeping the mu or the mean of that signal or noise level at the 0. So, depending upon that you can keep it at mu minus 3 sigma to mu plus 3 sigma level, okay, and model it as a Gaussian distribution. Now, you have impulsive noise, that is the, you can say, Gaussian noises or the background noise is always present. Impulsive noise, it is kind of a noise which comes suddenly and then dies out. Okay. So, impulsive noise in a power line communication refers to short duration high amplitude noise spikes. It is a spike kind of thing. It comes and then it dies out. After some time it will again come and then again it dies out. Okay. That occur randomly or periodically and span a broader frequency spectrum. And obviously, that amplitude of that impulse noise is very high compared to your background noise. So, it is caused by switching transient, that means let us say you are switching on one device. So, at that time you will get some sparking or you will get some high current, suddenly increase in the high current and then it will reduce. Okay. So, if that is the case, so at that time that has some interference with the your communication system. So, if at that time you see a sudden spike in the communication as well and then it will die out. If that is the case, so then we will say some impulse noise is present. So, depending upon the event, that appliance standing on off, lightning, arcing and electrical equipment, there are different types of impulse noises you can see. First one is the periodic synchronous, that means that impulse noise which is coming, that is synchronized or it will come in every certain, after every certain time period and it is synchronized with your system frequency, that means your 50 hertz power frequency, okay, and then synchronized with the system frequency or the clock, okay, caused by devices like switching power supplies, CFL, dimmer switches, motors with brushes or inverter based appliances. Okay. So, these are the few periodic synchronous impulses from the UPS and your CFL. This is a portrait. Then you have periodic asynchronous, like the amplitude or that short amplitude your impulses are coming after certain time period, but they are not synchronized with the main frequency, that means your 50 hertz frequency. Okay. Their frequency might be different. If that is the case or normally generated by the SMPS or inverted PWM cycles, because PWMs are normally very high frequency switching events. So, not 50 hertz, that will be kilohertz level. So, if that and if that causes, then you are switching on a thyristor or an IGBT. So, that will create a spike in your communication as well, that will have some interference with your communication medium signal as well. So, then it is periodic because obviously your IGBT switching will be with a certain gate logic, okay, like when the pulse will come, depending upon that it will be switched on or off. So, it is a periodic event, but the frequency of that event is not synchronized with the main 50 hertz frequency. So, at that time we say that it is a periodic, but asynchronous impulses. Then if I am completely aperiodic or random, so that is short duration noise spikes with no fixed pattern caused by switching transient relays or electrical arcing. If there is any short circuit or let us say arcing happens or lightning strikes is there. So, that is a random event that never happens regularly, suddenly it will happen and then it will die out. Okay. The short duration of the impulses result in their energy being spread across a broad frequency spectrum, making them difficult to filter out. So, more dominant in PLC. So, you can see this signal is going like this and then suddenly you have a spike in the noise, spike due to the noise in the signal and then it will die out again. So, this is called the switching transients. So, how you can model your impulsive noises? So, amplitude, width and inter-arrival time between the impulses are the three major parameters to be considered for modeling the impulsive noises. Okay. So, impulsive noise never comes alone and it always mixed with the background noise, because background noise is always present in the circuit. So, whenever an impulsive noise comes, it will be superimposed or it will be added with your background noise. So, generally this is modeled as with the help of Middleton class A statistical model, that is a Gaussian mixture model. So, if you use this with a proper weights and the arrival of this impulses are modeled with the help of Poisson distribution, and this is your Gaussian model. So, this is the entire Gaussian mixture model, where the standard deviation of your impulse or variance of your impulse depends upon the variance of the background noise. Okay. I is the impulsive noise index, delta denotes the power ratio of the background and the impulsive noises. So, if you add them together with your background and the impulsive both, then you can sum it as this equation, where if it is I equals to 0, that means there is no impulse. So, at that time it will represent only background noise. If your I is greater than 0, that means I equals to 1, that means there is only there is only one impulse. Then if you have 2, then you have 2 impulses, 3 and henceforth. Okay. Then what are the noises in optical fibers? So, optical fiber communication is known for its high bandwidth and low attenuation. So, that means the signal quality is good whenever you are sending, it is less prone to be affected by the noises, but still there are some noise. What are those noise? These noises are thermal noise, short noise, amplified spontaneous emission noise and nonlinear interference. Okay, you can see AC, short, thermal and NLI. And NLI due to 4 wave mixing, self phase modulation and cross phase modulation. These are the causes for nonlinear interference. So, generally these two noises AC and NLI are more dominant in the optical fiber. The short noise and thermal noise are little bit lesser. So, we can neglect them, their effect. So, which are the AC noise in the optical fiber and what is the cause of it? Amplified spontaneous emission noise refers to the optical noise introduced during the amplification process of a signal in a fiber medium. Okay. This exists excited ions, that means whenever we will send the excited or the by the lighting events, they will emit some photons. So, sometime without even having any data, it is not carrying any data, but that photons will emit energy. So, that energy will be added and with the your sending signal, and that will cause that amplified spontaneous emission. So, that is the spontaneous emission, not controlled emission from the photon energy from the ions, and that you cannot get rid out of it. So, this spontaneously emitted photons are indistinguishable from signal photons and get amplified as they propagate through the gain medium. So, when you will put an amplification, so that unintentional or that unintended photon energy, that will also get amplified. So, you will have more AC noise when you have an amplification. So, since spontaneous emission occurs constantly during amplification, AC noise is continuously generated and accumulates along the transmission path and more for long hauls. So, if you can see, if you have a simulated emission, you are sending a ion from a ground state to the excited state and then it is sending the simulated emission, that is your data. But whenever this unexcited or unwanted ions, they also get, because if you are sending some signal, you cannot control, like it is not like only few ions will be excited. Some ions which are not needed to be excited, but that will get excited and that will go to the excited state and then you will get the spontaneous emission. They are not carrying any signal, they are just added as a noise signal. Then AC noise in optical fiber, how can mathematically that power is seen? The spontaneous emission of the light appears during the optical signal amplification and it is not correlated with the actual signal. This is only additive in nature, they will be added, their amplitude. The noise introduced by the spontaneous emission has a flat frequency characteristics by the Gaussian PDF. Okay, this is a example of looking at your spontaneous emission. Okay. The total power of the spontaneous emission noise for an amplifier followed by an optical fiber bandwidth of del f is given by this power expression. Okay. Then h mu is the signifies the photon energy, and the factor 2 accounts for two polarization modes of the light. Okay. There are two polarization. Then you have nonlinear interference. Okay. What is nonlinear interference? Nonlinear interference noise is the optical fibers arises from the nonlinear interaction of the optical signals with the fiber medium, okay, leading to unwanted signal distortion and the generation of new frequency components. Whenever your actual signal it interact with another signal, let us say there is not only power data is going, right. If you have a dedicated medium, then it is fine, but sometimes the internet data and your power data both goes together, the communication data and your power system data. So, these two data will have different frequencies, obviously one is at the let us say 10 kilohertz, one is at the let us say 20 kilohertz, but they are sharing the same medium. So, it is possible that they will have some interaction or interference among each other. Okay. So, if that is the case, then we call it a NLI event, nonlinear interference event. So, NLI is generated due to interactions among co-propagating channels or between the signal and AAC noise. So, AAC noise you always have. So, that AAC noise has different frequency level, even your signal has another frequency level. So, this noise and the signal they can interact with each other and they can create another noise. So, that you can say an cascading events, okay, and that can affect or degrade the signal quality and limiting system performance. So, NLI noise primarily arises due to nonlinear effects like 4-wave mixing, self phase modulation and cross phase modulation when multiple optical channels propagate through a fiber simultaneously. So, normally if you see optical fiber, there is thin channels are there. So, they are tightly bunched together and then it is used. So, that interference between these different channels, that also causes a nonlinear interference noise. So, what is self phase modulation? The phase of a light signal is modulated by its own intensity, leading to spectral broadening of the optical pulses. So, with own signal, due to its own interference, it is causing a modulation effect. Cross phase modulation, a signal's phase is modulated by the intensity of neighboring channels. So, another optical fiber channel is there neighbor to it and it is carrying let us say another signal of other frequency, then they are interfering, having some interfering with each other, and that will causing intercrosstalk, especially in the wavelength division multiplexing systems. Then 4-wave mixing, 3 co-propagating waves, that means one optical fiber is shared by 3 frequency events or 3 frequency datas. So, if they can interact within the fiber to produce a 4th wave. So, these 3 they will interact like 3 different frequencies, they will interact and they will generate another signal with different frequency, okay, and that new frequency causing interference and signal degradation. So, the NLI noise also follows the characteristics of Gaussian probability distribution with 0 mean and your definition of and standard deviation of sigma. So, this is the combined effect of both AC and NLI noises is mostly represented by the enhanced Gaussian noise model having 0 mean and a variance dependent on the higher order noise signals. So, this is given by this. So, the simplified model is characterized by a Gaussian distribution function with this total variance. This is due to the AC and due to the NLI. So, this is generated by a normal distribution. Now, experimentally it is found that the average variance values of both NLI and AC noise are approximately same. So, the summation is given by 2 of your sigma wave square. So, if you put this value, then you will get a single equation for combined effect of these two noises. okay, and this combined effect is physically also justified, because we have seen that if you have a signal sending, so AC noise will inherently it will have AC noise, and that AC noise and the signal, they can interact with each other and then they can cause the NLI noise. So, together we see this combined effect. Okay. With this, I will end today's lecture, and we will continue with different other kinds of nonlinear characteristics or non-ideal characteristics of the communication medium in our next class. Thank you.